In this video, we'll demonstrate the Interactive Model Trainer, or IMT, a tool designed for the training of topic models on user-provided collections following a user-in-the-loop approach that allows the incorporation of domain experts' knowledge into the model, resulting in final models that are more easily interpretable for end users. The view we have been seeing until now is the main page of the application. The first step for a user to use this platform will be to authenticate. Once authenticated, at the top, we find 4 tabs, each representing one of the IMT's main functionalities: corpora, models, word lists, and a home button for easy navigation back to this page. These functionalities can also be accessed via buttons under the Start view. Additionally, the main page provides 2 shortcuts for user convenience. In the center, we can access recently trained models, while on the right side, there's an overview of the actions available within each main functionality. This layout ensures intuitive navigation and efficient access to the offered tools and features. If we navigate to the Corpora tab, we'll notice 2 distinct types of corpora available: raw corpora and logical corpora. Raw corpora consist of datasets downloaded from Intelcom's data catalog, while logical corpora are subsets of raw corpora specifically created for domain selection or topic modeling purposes. It's important to note that a single logical corpus can be constructed from multiple raw corpora. Let's begin by examining the raw corpora view. Here, all available corpora are listed in a table along with pertinent metadata such as description, number of entries, or source. Users have the option to filter raw corpora by name or download date. Additionally, users can click on any of the datasets to access more specific information, displayed on the right-hand side. In these information tabs, 2 buttons are visible alongside the metadata. The first button showcases corpus fields, presenting all available metadata associated with the datasets. The second button allows for the downloading of the dataset schema as a JSON file. Additionally, at the top of the side panel, we can notice buttons for renaming or updating the description of the raw corpora. Raw corpora form the basis for logical corpora used in training, so no further action is required from the user here. In the Logical Corpora tab, users can access corpora for training domain models or topic models. These corpora contain descriptions derived from raw data processes, subsets, and field combinations. They do not store raw information but provide guidance on accessing it. Again, users can filter logical corpora by name, date, creator, or use for domain classification or topic modeling. To create a new logical corpus, simply click the Create Corpus button. From there, you have 2 options. You can either create a corpus using a form, or import an existing description from a JSON file. For instance, let's walk through creating a new logical corpus named demo_test for the topic modeling. We'll add the description OA_KWDS3_AI.parquet as our corpus. Now, we must indicate how we want to utilize the available metadata during model training, selecting an ID and at least 1 item to be used as lemmas for the topic model. We'll leave private unchecked to make this corpus accessible to everyone. After reviewing our selections, we can save the corpus. Upon creation, we'll receive a confirmation message indicating that the corpus was successfully created without errors. Now we can inspect this new corpus by clicking on it. Again, on the side panels, we can see the metadata of our logical corpus, as well as seeing the corpus fields and download the JSON of the corpus generated. We can also rename or delete elements. Renaming prompts a dialog with the current name and a field for the new name. Deleting requires verification as it's irreversible. For example, let's just delete the corpus we just created. Now let's navigate to the Topic Models view. Constructing a topic model on a corpus involves extracting the topics composing that corpus in an unsupervised manner. However, to ensure the model's utility for end users, it has been demonstrated that involving humans in the loop to refine the initial model output is crucial. This tool enables users to effortlessly train, inspect, and curate topic models, aligning them more closely with their expectations. Again, we can see the already trained models through the table located at the center of the screen, together with some metadata. And we can filter them based on its name, type of topic modeling algorithm used for the training, creation date, and creator. The process of creating a new topic model follows a similar approach to that of domain models. We begin by clicking on the New Model button located at the top of the listing table, which prompts the training model form to appear. Let's proceed with the creation of a new model. We need to input the name, description, select the corpus for training, choose the training algorithm, and configure the model parameters. Currently we offer 4 different types of training algorithms, 2 Bayesian-based options, Mallet and Spark, providing various implementations of LDA, and 2 neural models, Prod LDA and CTM. Depending on the chosen model type, additional parameters may need adjustment. Advanced training and pre-processing options are available for all models. Each parameter includes a brief description to aid users unfamiliar with its purpose. For this demonstration, let's train a model on the Cordis_KWDS3_AI using Mallet with default parameters. After clicking Create, a new task is initiated. We can review this task by clicking on the running tasks below and examining its logs. It will take approximately 1 minute to complete. However, for now, let's hide it. In the meantime, let's explore an already trained model, like OA_KWDS3_AI_25TPC, which is one of the models that has been used for extracting the indicators shown in the STI viewer. By clicking on the model, we can explore additional information. In addition to the right panel we've seen in other views, at the bottom of the window, details about each topic are displayed. This includes labels describing the topics, manual descriptions, and metrics such as topic size and the number of documents where the topic is active. Topics can be filtered by their labels. Or keywords in their description. Clicking on a topic reveals extra information on the bottom of the right panel. Moreover, users can utilize the New Submodel button to create a second-level model from that topic. This opens a window similar to the one for training Level 1 topic models, with additional parameter options. A 2-level hierarchical topical analysis is valuable for exploring broader topics found at the first level. If second-level submodels are available, they are hierarchically listed in the models table, as it is the case for the OA_KWDS3_AI_25TPC model. Apart from training and inspecting topic models, from the right panel we can also perform some managing options as we did in the previous windows. We could also inspect the training parameters used by clicking on the Show Training Parameters button, and also visualize a graphical representation of the topics by clicking on Show LDA Visualization. In this figure, on the left, we see a map of topics represented by bubbles. The size of each bubble corresponds to the topic's importance. Similar topics are grouped closely. A uniform distribution of topics across the mapping space indicates that a successful optimization of the model has been achieved. Let's now inspect the curation. For doing so, we need to click on the Curate button, which gives view to 4 curation options. We could manually modify the labels assigned by the automatic labeling tool. We can look for similar topics, based on either if they co-occur with relative frequency, or if the words characterizing them are the same. To do so, we must select the number of pairs of topics to examine and the similarity criterion to be used. Based on the similarities found, we can choose to merge some of these topics. Also, we may want to sort them according to size or delete some of the topics, for which we also have dedicated windows. If any of the changes made do not meet our expectations, we can always reset the model to its after training state by clicking Reset Changes. Finally, let's explore the Word Lists tab, which comprises two tabs with similar functionalities but distinct purposes. Keywords are lists that contain a number of terms that are related in a certain way and will define a domain. For example, cancer, carcinoma, neoplasm, malign are words that could be keywords in the domain of cancer, in which case, we would want to create a domain model about cancer. Stop words and equivalences are essential for pre-processing in topic modeling. Stop words are terms that offer little characterization to topics within our domain. For instance, in a corpus focused on artificial intelligence, including the term AI in a chemical description adds little value since we already understand the topics revolve around AI. Equivalences, on the other hand, address lemmatization errors or unify terms under a single concept. For example, machine learning and ML can be unified as machine learning after lemmatization. Apart from listing available word lists and filtering them based on its name, creation date, or creator, this view lets us create new lists by clicking the Add plus List Type button, in this case, the Add Stopwords button on the top right corner. We can import a list from a file or manually create one. If importing, we'll name the list, select the file, and review its elements. Alternatively, we can manually input elements, each accompanied by a description. A panel displays all added terms, facilitating the process. The interface for adding equivalences resembles that of adding stop words, but involves pairs instead of single words. Clicking on a stop word reveals information about it in the right panel. Again, we can see the management buttons on the top of this right panel, which allows us in this case to rename, edit, copy, or delete list.